Bismillahirrahmanirrahim. Assalamu alaikum. This is lecture 11th of the Artificial Intelligence course. So far we have talked about the uninformed search algorithms that can find solutions to problems by systematically generating new states and testing them against the goal states. Unfortunately, these strategies are incredibly inefficient in most cases. They do not use any knowledge about the specific domain to search through the state space in a more directed manner. If the search space is big, blind search can simply take too long to be practical. This lecture will consider informed search strategy, the strategy that uses problem-specific knowledge. As it is obvious from the name, informed strategy, that these methods will be having some initial information or knowledge, such as how far we are from the goal or how to reach the goal node, etc. This knowledge helps the problem solving agent to explore less to the search space and find more efficiently the goal node. This is a review slide defining the artificial intelligence in terms of a problem solving agent. A problem solving agent usually performs searching in order to achieve the goal. A search problem mainly consists of a state space, the set of all states reachable from the initial state. A start state is the state from where the search begins. A goal test is a function that looks at the current state and checks whether or not it is the goal state. The solution to a search problem is a sequence of actions called the plan that transforms the start state to the goal state. Gn is the cost from the initial state to the current state, and Hn is the estimated cost of the cheapest path from node n to a goal node. And Fn is the evaluation function to select a node for expansion, which is usually the lowest cost node. We have already discussed the blind search or the uninformed search algorithms that includes breadth first search and depth first search and uniform cost search algorithms. Now we will consider the informed search algorithms that has some heuristic search. In the heuristic search, we have a rough idea of how good various states are and use this knowledge to guide our search. The informed search algorithm is more useful for large search space. Informed search algorithm uses the idea of heuristic. It is therefore also known as heuristic search algorithms. Heuristic is a function which estimates how close a state is to the goal. It takes the current state of the agent as its input and produces the estimation of how close agent is from the goal. The heuristic method, however, might not always give the best solution but it guaranteed to find a good solution in reasonable time. It is represented by Hn. In previous slide, we defined Hn as the estimated cost of the cheapest path from the node n to a goal node. So actually it calculates the cost of an optimal path between the states. If Hn is a heuristic cost and H star n is the estimated cost, then heuristic cost should be less than or equal to the estimated cost. When searching for the shortest path on a map, suppose from Kohat to Lahore, a good guess cost or heuristic is the straight line distance. As we see that by road distance is longer than the traveling by plane. As that consider the straight line distance. So consider we say that the shortest path from Kohat to Lahore is the straight line distance. This path guesses the distance without obstacle, that is without mountain, curves, turns, bridges, etc. It is just a straight line on a map from Kohat to Lahore. This can be done by estimated the Euclidean distance between the two states, or you can say two cities. So that distance is known as heuristic distance or heuristic cost between the two cities. Consider at heuristics for the 8 puzzle game. This example will shed light on the nature of heuristics in general. The 8 puzzle was one of the earliest heuristic search problems. As discussed in our previous lecture, that the aim of the puzzle is to slide the tiles horizontally or vertically into the empty space until the initial configuration mates the goal configuration. If we want to find the shortest solution, we need a heuristic function that never overestimates the number of steps to the goal. Here are two solutions. The first heuristic is the number of tiles that are in the wrong position. And the second heuristic is Manhattan distance, which is the sum of the distance of the tiles from their goal position. Because tiles cannot move along diagonals, the distance we will count is the sum of the horizontal and vertical distances. This is sometimes called the city block distance or Manhattan distance. Consider this arrangement of the start and goal states. We'll try to solve it using heuristic 1, which is counting of the number of the tiles out of place. If we see the initial, if we look at the goal state position in the start state, tile 1 is not in its position. Similarly, tile 2 is out of place. Tile 8 is out of place. Tile 6 is out of place. Tile 7 is out of place. While tiles 3, 4 and 5 are on their correct position as goal states. So we can say there are 5 tiles that are out of place. So we can say that the heuristic is 5. This means that this arrangement will take at least 5 steps to complete. That is, the arrangement cannot be solved in less than 5 moves. There must be at least 5 moves to complete the task. The same problem can be solved using Manhattan distance. That the distance or the moves that a single tile required to get to its desired location. Here we can see that looking at the goal state, we see that tile 1 required one step, one move or one step to go to its correct position. So we write 1. Similarly, tile 2 need one step to move to its correct position. So we add 1. Tile 3, 4 and 5 all in its correct position, so they need no step or move. Now tile 6 needs one step to move to its correct position. So we add 1 here. Similarly, tile 7 need one move or step to go to its correct position, and tile 8 needs 2 position. If we move this to this, or if we move 8 from here to here, then they require 2 steps to move. So the total number of moves that need to complete the goal state require at least 2, 3, 4, 5, 6. 6 steps. This is known as Manhattan distance. Now consider these examples and try to solve this using heuristic 1 and heuristic 2. The students can tally their results with these slides. Thank you.